Hi, my name is Junko Yoshida. I'm the editor-in-chief of the Ojo Yoshida Report. Today, you are in this special session called AI Lifecycle, a pragmatic discussion of the cost of AI implementation. It's a little long title, but we'll get to this. Before we get to this exciting discussion, I have a few announcements to make. First, I would like to thank you for the sponsor, Win Semiconductors. Win Semiconductors Corporation is the first pure play 6-inch gallium arsenide foundry in the world. Win manufactures cost effective, high speed, and high quality gallium arsenide and GaN and INP MMICs and RFICs as well. So we provide dedicated foundry services to design design houses and integrated device manufacturers and supplies fabrication services to worldwide IC corporations. Thank you. So I have a few more housekeeping announcements, a few tips. First, if you have a question for this discussion, please click the Q&A segment. It's in the right-hand side, upper right-hand screen corner, and type your questions, and we'll get to it as much as we can and during the session. Second, if you have any technical difficulties during the presentation, use the chat session. Admin is available to help you out. And third, all presentations are this discussion is being recorded and will be made available after the live session. All right, without further ado, let me introduce our guest today for this particular session. We've got Brian Reamer, research scientist at MIT Age Labs. Hi, Brian.
Hi, Junko.
And we also have Phil Coltman, professor at the Electrical and Computer Engineering at Carnegie Mellon University. Hi, Phil.
Hi, Junko. Hi, Brian.
Yeah, so Brian and Phil, thank you for being with us today and call attention to what happens to, a lot of people talk about AI. Actually, a lot of sessions in this conference also about AI. But this is actually very special because you guys are calling attention to what happens with AI-enabled products down the road. This is something I had never thought about because we're still struggling can we get the AI products out on the market? So here we are. So two experts talking about AI-enabled products. But let me ask you, let me ask Brian first. Why did you come up with this AI lifecycle idea? Tell me. I mean, what was the genesis of your worries or the concerns? Can we start from there?
Junko, it's a good question. And I think that as we think about product life cycles in general, so much of our attention goes to the form and fit factor of how to get a product to market. But the more complexities behind that, in essence, for this conversation, the more AI intelligence and computational hardware behind that, the more we need to begin to think about what happens to this product post-deployment. At the end of the day, maybe 50% of the complexity and even a small percentage of the cost is embodied in getting a product to market. Once that product is now distributed to the masses, in the case of cars, tens of millions of people in the US, more than that globally. In terms of a product life cycle of the new iPhone 16 released today.
Yeah.
Released to, tens of millions in months. Once that product gets to the hands of the consumer, the true costs begin to play. So that's in maintaining the security, the usability, the functionality for a smartphone for maybe a 10-year life cycle.
Yeah.
Now, not 10-year life cycle with me, 10-year life cycle when it moves down the chain through the third world. A vehicle brought to market today is likely to exist for 2 decades or more. Relying on AI systems and security in electronic componentry, chips and the like, that 20 years from now will look like archaeological digs, let alone our ability to go find this chip and fix it. And our thoughts on what cybersecurity or protections look like, historical in nature. But yet we do need to leverage some of these advances if we're going to see the benefits impacting us. So that doesn't mean stop the presses. That means begin to set a vision for the first challenge is getting this to market.
Yeah.
And the second challenge is, how am I going to maintain this durable product life cycle, as Phil said earlier on, throughout the next 10, 20, 30 years?
That's a really good question when you think about AI is the newest, I guess, shiniest thing that everybody wants to talk about, but people really don't want to talk about after that got into the products, commercial products, because who's going to take care of that, right? And so one of the things I want to ask Phil Koopman, he is my mentor on did you think of that hashtag? And so tell us what actually concerns do you have of AI-enabled vehicles or AI-enabled consumers once that is in the hands of the public?
Well, everything has changed with AI because we used to have this fiction, especially with the car. Then when you shipped the car, when the car rolled off the dealer lot, that was it. That was the car you were going to get. And 20 years later, that was the car. But let me inform my perspective with a little background of how I started worrying about life cycle. So I started out right after, my undergrad degree was paid for by the U.S. Navy, because back then that was the middle class scholarship, was Navy, ROTC, or Air Force or Army, take your pick. And I drove submarines for a living for a while. And the submarine I was stationed on, the keel was laid the year I was born. And it was midlife. Okay. And it already had a new combat system. We had computers as opposed to the mechanical stuff that was in the older boats. We had computers. Wow, it was pretty cool, right? With real core memory and all sorts of stuff like this. And this is in the early 1980s. So, and that boat was around for, I don't know, for that particular boat, it was like a 40-year life, something like that. Okay. And end of life had more to do with the Cold War ending than anything else. And so I, early on in my career, really saw up close and personal what happens to these long-lived systems. And after that, I was stationed with the Trident submarines, and we were doing the software integration and shipping out updates and doing life cycle. So combat systems, especially the big expensive vehicles, they're looking at 10, 20, 30, B-52s might be 100-year life cycle. And so thinking about life cycle is just what you do. That's just how you think. Then I went into the commercial industry, and we're going, well, here's a MP3 player with a life cycle of 6 months, and so
get the new one, right?
Yeah, and it's basically disposable electronics. It's just night and day. So then when I spent some time in the car industry, and I started asking myself these questions about, I had one adventure, I shouldn't say which domain, but it was neither of those, where a company had forgotten to make the end of life buy on chips. And now they're looking at $1 million bill to reinvent a chip or write a simulator. Fortunately, somebody had some old wafers and they had to pay through the nose to get the old wafers packaged. And, there's a whole business for, how much those wafers cost? Well, how much you got? So there's all sorts of, through various adventures and misadventures in my early career, I kept hitting end of life as a continuing theme. So now when people say, oh, we're going to do software updates, and I start saying, you're really going to do a software update for a 15-year-old CPU and it's going to run the same software as your new car? I don't think so. So I sort of got into it there. So now with AI, okay, now back to your question. Thanks for the diversion, but I mean, I got to by an interesting path. And these are the kind of experiences that teach me you can't just ignore this stuff. Whereas the consumer electronics industry never really worried about it because they didn't have to. Right. But as soon as you're putting this kind of technology that evaporates pretty quickly into products that last 10, 20 years. Brian said 20 years. Well, the average car life in the US is north of 12 and a half years now. And as Brian said, when they're done here, they get sent to other countries, right? So, right. And you start asking questions like, well, if it doesn't have a software update, does that brick the car? And if the software update is to fix a safety problem, do you want the car operating without the software update? And if the software update is to put in the latest HD maps for the self-driving feature, and the map company goes out of business, or the car company goes out of business, and now when you export them to other countries, okay, maybe the self-driving works, but it doesn't work, but maybe there's no steering wheel, so now it's useless, it's junk. Or maybe somebody didn't think clearly, and there's a feature that depends on a cloud server that makes your car, all these IoT things that get bricked when the server goes out. Well, what if a car company does that? So I don't know. I've just put like 20 things on the table, but anytime someone says our plan is to continuously deliver software updates, I immediately say, and 20 years from now, what's your plan?
See, this is even more problematic with AI in many ways, because we don't know what comes next with AI 5 years from now, or maybe even next year, right?
So what's interesting here, Junko, is that you see the business models among, we'll stay with automotive for a second. You see a business model shifting to, we'll do a subscription-based service for up to 8-10 years after the vehicle is launched, trying to sandbox the risk, okay, on an assistive driving feature.
Yeah.
The risk for them.
The risk for them, the value of the commodity to the consumer. But what they're not sandboxing off is that all the fundamental control and active safety systems are going to suffer from a lot of the same issues. That we sandboxed off the assistive driving feature won't work anymore. But what about the AEB systems that we are slowly pushing towards higher standards for? Are we going to turn these features off when they go to the developed world, where the risks of auto fatality are magnitudes greater than they are here in the US? So I listened to Phil start this off about his history on where he comes from. My master's thesis 25 years ago was on end-of-life recycling logistics. What do we do with the electronic waste? And at that point, much like a lot of the issues we're dealing with today, is the best approach is to design for it up front. So you can design it so you can disassemble it. Okay, you can deal with these issues a lot better. If you can design the electronics that we can deal with the limitations of software complexities, whatever that may be. And that may be modular designs where you bring a new computational system into the vehicle after a decade and design for that up front. Elon does seem to be thinking ahead there a little more than a lot of other folks. For better or for worse, the concept of the computational systems behind these vehicles or other durable goods need to be thought through up front. I mean, we're increasingly creating refrigerators and washing machines that talk to us. If we really do like these features, they're not going to talk to us so well in 5 years. I mentioned the iPhone up front, and everybody thinks the iPhone, well, that's just another consumer product that'll disappear. But these are $1,000 plus computers that aren't just disappearing anymore. They're sticking around for longer and longer, exposing different vulnerabilities along the way, and then end up, going from the U.S. to a second market, to a third market, et cetera.
Brian, when you talk about this life cycle issue in a fast-growing market, or in a very, this market is just starting. Very few people are actually thinking about what you're talking about. They're barely putting a lot of emphasis on life cycle management. It's all about how much of the market can I grab at this moment. How do you change that dynamic?
Well, I think you have to change that dynamic by changing the culture of responsibility for products. And, we'll go back to where Phil and I do a lot of work in the car, is that your responsibility doesn't end with deployment. You can't dump it all off on maintenance and warranty costs. The manufacturer has to own the long-term software and computational component costs, much like we used to have to own the product life cycle to replace braking systems. But once you begin to factor those costs into the product life cycle, you begin to take a very different approach to understanding what should I do, how should I do it, how should I think through these problems, because you're not just thinking of the per unit cost, you're thinking of the per unit cost and long-term liability of the product decisions you're making. So I'm going to flip it around to a whole different topic for a second. It just nails the point home well. Electric vehicles. We're creating batteries for electric vehicles right now with very little thought of how do we dispose of those long term. If the battery cell manufacturers were forced to own the life cycle and recycling cost of those, they would take a completely different perspective on the manufacture of them. They'd manufacture them so they can be effectively recycled. Instead, hey, some other market will deal with that long-term cost. And the same is true for AI-driven systems and electronics.
We had a keynote earlier today with John Christoph Eloy with the Yale Group, and I was struck by something he said. When you look at the totality of the market on the hardware side, you're looking at anything up to $280 billion for AI, right? Within 5 years, going from almost zero to $280 billion within 5 years. And the question was, what applications are they chasing? What problems are they going to solve? What product? What's the usage? Well, that's the next phase. Now they're building the infrastructure, and then they're going to worry about the usage, the applications. This at this moment, okay, high bandwidth memory, and all of those things, that's their concern. That's the concern of the industry. The industry is not really focusing on life cycle management, on resolving the issues that you're talking about. And if you say that that's going to be resolved by forcing them, I'm not sure that's even coming up on anybody's thoughts right now.
Let me try a different approach, which is why they have to pay attention, even though no regulator is forcing them.
Okay.
Because those pressures are more likely to be what we see rather than regulatory pressure, and it's that's a whole different discussion how it should be, but I think that's how it will be. What you're seeing is people switching from, as I mentioned earlier, ship and forget to no. Our plan is we're going to have a revenue stream for this product for its whole life. And we're going to sell on updates, and we're going to sell on services. And let's talk about essential services. I mean, you have to make fun of the butt warmer thing here, but I'm talking about essential services like if you're going to do self-driving, well, you probably need some sort of maps, even if they're not high definition maps. You need maps to know where the off ramp is, right? Or regardless of what the accuracy is. And the world changes, and so you need to retrain your machine learning to deal with distributional shift in the real world. I mean, these things are inevitable. If you deploy AI, you are signing up for a lifetime of support for the machine learning to just deal with distributional shift in the real world, if nothing else. Okay, there's just no way around it. And if you put in this hardware that's all the resources you can afford today, well, those aren't going to be the same as the resources you can afford tomorrow, let alone 10 years from now or 20 years from now. And so saying, well, our plan is we're going to keep the software refreshed inside the vehicles, and we're going to do that for 20 years. The software that you can support on hardware 20 years from now has nothing to do with the software you can support today. And so what's your plan? It's not going to be the same software running everything. And there are two ways to go. One is you do product generations, and you're simultaneously have 4 or 5 generations you're maintaining. That's one way to go. That's what people kind of currently do. The other one is you can make it so that the compute guts get swapped out over 4 or 5 years. So this is what the military does. Every so many years, depending on the class of ship, they cut the submarine, they cut a giant hole, and they forklift out all the computers and forklift in new computers, right? When you're doing 50-year product life cycles, that you don't have a choice. You have to do that, right?
Right.
And so is there a slot where you just slide in a new tablet, every 5 years, or what's the plan? But I haven't heard people talking about this as a plan. And when you're talking about hardware, you're going to make chips for AI. Well, your chips 10 years from now are going to be different, and you can't predict what they're going to look like. I mean, seriously, you can't. You can predict, but you'll be wrong, right? So what's your upgrade path? And people say, oh, we have product families and we can scale, and that's great. Scaling in 5-year timeframes is different than scaling in 20-year timeframes. So these are the kind of discussions we need to have. And the answers aren't going to be easy, but the answers are going to be back to what Brian was saying. You're going to have to design for long life cycles up front, knowing that you don't know what it'll look like 20 years from now. So it means you have to make very shrewd guesses on what factors you can control and what factors you have to be able to make it up as you go.
And I'm going to take this one step further, because I wholeheartedly agree with Phil here, is that, the product life cycles are much smaller for durable goods. And the model the military has is dead on correct here. But even the properties of what we're looking to sense out there, vehicles will not be made with the same materials 20 or 30 years from now. Is it carbon? Is it something else? Is something else lightweighting? Radars and vision systems are going to have to be modified. So it's not just the compute hardware. It's likely all the sensing hardware as well. Maybe even, quite frankly, the network components. We look at those systems, a decade from now is a long time when we think about the bandwidth of information flowing around. Now, we talk about in auto all the time now, software-defined cars. Well, yeah, okay. Software is not going to look the same a decade from now. So you may be defining the vehicle based upon software, but it's the hardware componentry that's going to be harder to change. And quite frankly, over the course of a 20-year lifespan, unless there's a severe accident along the way, you're probably going to need a hardware update. And I think, again, Elon, I talked about earlier, is thinking there. The biggest issue actually to me is, without planning for this, is the cybersecurity vulnerabilities. There is an incredible force within the world. We talk about the potential influence going on in U.S. elections right now, but there is an incredible force in question of what will be the next major cyber attack, and its penetration on vehicles, portable electronics, something that has detrimental effects. Can only be through, quite frankly, long-term visions on how AI systems are going to need to evolve post-production.
I'm sorry, I have to bring up one company. I don't know if either of you even wants to touch it. NVIDIA. The changes it has made in just a couple of years in the GPU that it's rolling out. There's 100 and then HDs and HDAT and all of those things. And these things go into servers and all of that. And NVIDIA has a roadmap even for the next set that's supposed to come up within 2 to 3 years, because they have to keep ahead of the competition. I've not seen a discussion of what happens to any of this hardware. It hasn't.
So, Bola, there's two aspects. One is for hardware that's going in a computing center, in the data center, right? What you do is every 3 to 5 years, you throw away the data center and build yourself a new one, and then go refurbish the other one and ping pong back and forth. I mean, the cloud servers have like a 3 to 5 year lifetime. Last I checked, the numbers vary, but they're only, and why is that? Well, back when Moore's law was simpler, you could say, well, when it was, let's just say it doubles every year, just for the sake of argument. It's more complicated now by a lot, but let's just say it speeds up every year. Well, after 3 years, you can take 8 racks and replace it with 1. So I'd see these data centers that have, they're four bays worth of equipment and 1 empty. It's like, what's your plan? Well, the plan is in a couple of years, we're going to fill up that 1 bay and rip out all the rest, and then just do it again, right? And still grow the compute. And sure, okay, fine. You're going to throw away your cars every 4 years? I don't think so, right? So the NVIDIA question is, part one, to the degree they're building servers, sure, fine, right? But to the degree they want this stuff go in cars, we're back to, well, what do you do with a 10-year-old car that has hardware so slow it can't run anything new? That's related. There's a ton of medical equipment that runs on Windows 95 for various reasons, right? And it's not going anywhere.
Oh my God.
And there's going to be a ton of cars that run on whatever the stuff is now. And, you can only update the OS for so long before it's end of life. and before the hardware won't run it anymore, and we're back to, you know, what's your plan for 20-year-old equipment?
So I don't want this conversation to say, well, just because we can't maintain over the life cycle means we shouldn't do. That's not the right answer either. It's really a pragmatic planning exercise of being realistic to, we can't develop an incredibly high technology AI and electronic enabled system with the fallacy it's going to be around 25 years from now. We need to be thinking much more realistic of, okay, I'm developing in a system that I want to support. Maybe it's a decade. Maybe that's reasonable product life cycle here. And that at a point of a decade, the form and fit of what this fits into, whether that's a refrigerator or dishwasher or washing machine or a car, you know, the hope is that thing still exists. Otherwise, our cost of recycling and disposal technology is going to be astronomical. You know, at that point, we got to think about, okay, how do I update the components of this that I need to? I mean, no different than we don't expect the Freon in an air conditioner to last forever. We charge the Freon every 5x years, or we change the oil in vehicles every so often. Okay, wasn't expecting, cars aren't expected to run with the same oil as you took delivery on. It shouldn't be expected to run with the same AI systems. We need to be thinking much more realistic here. But what I think that does is it takes a lot of air out of this AI market right now and says, okay, wait a second. We talk about how many hundreds of billions of dollars of opportunity there is. Yeah, there is. But we need to be thinking about how we realistically achieve the optimal benefits while thinking about the long road needs of the consumer for the technologies we're creating. Otherwise, all we're going to do is fill the landfills with more electronic waste.
Let me come at this a different way and offer an idea, not that is necessarily the one true idea, but just to give you an example of their ways out of the box. So re-articulating this, what you have is, Brian and I think he can violently disagree if he wants, but we're both agreeing that I think that if you shovel a bunch of AI into a product now and make the world's coolest product and it's worth it and it's perfect in every way and everything's great, there's no way that for the next 25 years you're going to keep updating it to the latest and greatest without something breaking. Something's going to break, and it's probably going to break sooner rather than later. 3 to 5 years, that model's just going to break. So what are your choices? Well, your choice is after about 5 years, you just you fork that one off and say, well, that's the old product, and we're going to maintain it and still update it. But now we have the new one. Okay. And that now you're into like spare parts for cars and this kind of stuff. Right. And that old product. But the problem is, if to the degree you're counting on the AI to be mission critical and the AI needs to be updated, you've really grabbed on this huge maintenance burden. And if you're selling cars, how you plan you make your money off of software updates for 20-year-old vehicles being sold to people who can barely afford a 20-year-old vehicle? Well, where's your revenue coming from? That's going to break. Okay.
Yeah.
So you can do that. And the question is, how do you get out of that box? How do you support 20-year-old vehicles being sold to people who don't have a lot of money to pay you support fees to maintain this ancient technology that you have to go down to the local computer museum to find to run your software, right? This is the thing. Remember 7-track tapes, right? Okay.
Yeah.
So now let me give you an out-of-the-box way to do this. It's very simplistic. You could say, all right, we're going to design for 10 years. I'm making up numbers. We're going to design for 10 years. We have a new car. We're going to ship it in 10 years. And after 10 years, we're going to brick the entire computer-based functionality. It's just going to turn off. Okay? Because that's what's going to happen, whether they say it or not. I think that's what's going to happen, whether they promise it or not. As an effective thing, after 10 or 12 years, they're going to turn it off because they can't afford to maintain it. There's no revenue. So what happens now? Well, you don't want to throw it in the dump. Robo-taxis aren't going to save us in the next 10 years to make it so they wear out in 10 years because they're used 24. There's so many, but we're not going to go there. Okay. What do? Well, maybe what you do is you make it so that the electronics is a module you unbolt. And there's this great secondary market for aftermarket electronics you bolt in. And they're not fancy self-driving. They're basic vehicles. But you have this vehicle that works and it does steering and it does brakes and it doesn't do self-driving. And now you have an inexpensive car and that car gets sold overseas or whatever. I mean, there are ways out of this box, but no one's talking about this problem, much less ways out of the box.
And Phil, what I love about your example here is it's not new. Look, we had aftermarket engines, transmissions. This is not a new phenomenon of replacing componentry with something better, something newer a decade or two down the line. It's just we have to take the same mindset towards electronic systems and AI. And the more we proactively plan for that, the more successful we're going to be at fulfilling the promise of the life cycle we're looking for. So whether that's today's manufacturers planning for it, today's suppliers, or third parties beginning to plan for it, the key is collaborative discussion of that. So if manufacturer A is not going to handle this, being honest and transparent with opening the business opportunity for the aftermarket supplier. Don't block them. Work with them now. Enable them so that they can build the off-market parts to solve this problem a decade from now. May not be your business model, but you got to enable the other piece of it. Otherwise, quite frankly, the manufacturer should hold that liability. So unless they're going to help with that product life cycle and shift the open market for someone else to support that, got to keep it here.
Pick a number of years, and the manufacturer is obligated to provide 100% support for whatever they sold the customer for that number of years. And after that timer expires, if they want to not hold the bag anymore, they have to make it very easy for someone else to step in, right? And so you're not building disposable cars.
Yeah, and Phil, where I say easy is you can't say after X years it's now time to open it. You got to be proactive with that up front. You can't make today's American businesses in particular would love it. We're going to hold the control until D-Day. No. No one can solve this at D-Day. You need to solve this 7 years ahead of D-Day.
Well, the aftermarket needs 2 to 3 year ramp up to be able to be ready to go on day one. Yeah.
Now, the hard part here is that this changes the business model overnight. Is that okay? There are aftermarket providers that are going to provide significant more value to the vehicle platform or the durable good platform after its life cycle, competing back with the original manufacturer's interest. So we do need some cohesion here. The original product manufacturer would love to just sell a new product, but that's not a realistic answer for the consumer. I mean, average car in America is $45,000 in round numbers.
People are taking out mortgages to buy cars. I mean, that's what it amounts to. Yeah. The other, don't forget, this also has a resale value. So if you're doing a lease or you're planning to resell your vehicle, if that vehicle is near zero worth after 10 years, either because it won't be supported or some value because it has to be refitted, you're going to see faster depreciation. And I suspect that the current used car market is not really factoring the cliff that's going to come when these manufacturers can't support their vehicles anymore. But I don't know what it is because we don't know how that's going to turn out. I just think assuming that they're going to support all these fancy software features forever is not a great assumption.
Now, there's a number of tools, I think, Junko and Boa, that could be used here to incentivize the market. So let's go. We're talking about semiconductors here.
Yeah.
The semiconductor industry said, look, the life cycle of our semiconductors is only a decade. Okay, you can buy them, but at the end of the day, we are not, suggesting that this semiconductor is going to be a valuable product to support after a decade. That shifts the responsibility back up to the users to do something different. What is the true life cycle in a different application? The supplier base, wherever we are in that supply chain, has a voice to play, because at the end of the day, the durable good manufacturers, whether they're a car or refrigerator, are only going to try to push the responsibility down the chain. That means that the folks down that chain need to speak up with realistic answers, whether they're software providers or they're hardware and semiconductor producers.
That's fascinating, because it is the fallacy that, because right now AI is the solution for all the problems we have. And what you guys are saying is AI is creating all these unintended things that they didn't even think about. They didn't even want to bear burden. I mean, that's what you're pointing out. I mean,
it's not just AI. It's
Yeah.
software-defined vehicle, but AI is the poster child for all the problems.
Exactly. So what's interesting here is that we need to rethink the whole business of it all. And look,
Right.
you've seen a number of articles out recently on the fact that the AI economy is not producing the revenue for most. There's a small number of businesses who are actually generating value on this AI economy.
Yeah.
And I'd argue that's not going to change until we have a different mindset on the problem. It's not that AI is bad. It's great. It's going to do things. It's doing things and will do things that are phenomenal. But we have to have a mindset shift on how we build systems that leverage high technology. Otherwise, quite frankly, we're going to start we're going to pointing fingers later on of why do we do this? No one wanted to answer that. No one wanted to ask and discuss the true problems.
Well, who would have thought? And the answer is, we thought, just no one wanted to hear it.
Brian, when you came up with this topic, you were emphasizing the pragmatic part to it, and I thought that was fascinating. The only question I have for you is, who is going to take the lead? I mean, you use the word we, but a lot of what's going on now is everybody just diving in and trying to carve out a niche for themselves. So who should take the lead? I mean, the same thing applies to Phil's angle on it. There has to be a solution. It has to be pre-planned, and we need to start doing the planning now.
Well, I think there's a theoretical answer and there's a pragmatic answer.
Okay.
The theoretic answer is the product manufacturer should be leading the way here. At the end of the day, they own the product. They should be defining how the life cycle looks, et cetera. That costs money. They're not incentivized to right now. There's no regulatory push to. So the answer is they're not going to. So the theory is not going to work. So the realistic answer is I think that the legal and judicial system in the 5 to 10 year range is the ones who's going to force a product change here. And I hate for it to go this way, but you can see the writing on the wall for a large class action suit against some manufacturer of some side of you promised us and you failed to achieve. Now, I hate for the legal system to be the checks and balances for what should be proactive product management, but that's the way I see us going here. So I really hate the negative here. I really wish the players and the manufacturers of cars, durable devices, electronics would say, hey, we have to think ahead. We have to offer a product solution that meets expectations over the life cycle of the product. But unless there's a pushback, now I could see a couple pieces change here. Now, if there was a regulatory push to ensure that manufacturers took the liability for batteries right now, okay, which I think the manufacturer should take that liability, life cycle liability I'm talking about. So if Tesla had the life cycle liability for all the battery electric vehicles that they put into the market of what to do to recycle the batteries, there'd be a completely shift in mindset on battery electric vehicles. The same philosophy would call people to question the life cycle costs in other areas. So I think there are things that could be done regulatorily to kind of push us in a better direction on topic areas that absolutely should be addressed. And I say this in batteries because if we design for disassembly, we'd be causing and designing for a lot less environmental harm than we truly are today.
Yeah. Let me give an example of how bad it is, and then another way to do it without because big regulatory hammers and the legal system and a big regulatory hammer are never the most efficient way to solve problems. But this is what happens when the industry decides not to solve its problem, right? But how bad is it? When I bought a car a couple of years ago, and it comes with a data plan. It's like, okay, cool. How much data time? Oh, it's included for 3 years. How much will it be after 3 years? We don't know. We're still figuring that out. That is a direct quote. Okay. Well, it's been 2 years. Haven't heard yet. I have no idea what's going to happen in here. Okay. Fortunately, not a lot in my car cares about the data, right? I can remotely lock my doors, and that's about it. And I use Wi-Fi for software updates, so I'm fine. But I mean, they're just making this stuff up as they go. All right. So what is the kind of thing we're going to need to see? Well, another example is going to be that if you're doing all this really cool and provides value and people willing to pay for it, and the world is a happy place based on AI and constantly rolling software updates, the car companies at the very least need to promise that they're not going to brick your car after so many years. Because the first time they brick a car, resale values are going to go down into the basement. I mean, it's going to, enlightened self-interest should tell them not to brick their cars. All right. So what do? Well, you somehow come up with a way to make sure your car no longer needs such intensive care and feeding. And that may be that your AI features don't work, or it may be that you come up with some reduced active safety, but not self-driving. So they, as a practical matter, they're going to have to figure out when they want to end of life real-time support, that they're going to have to re-engineer the system to no longer need the support and still make it a viable car. If it can pass, well, FMVSS has all these issues, Federal Motor Vehicle Safety Standards, has all these issues, most of which is it has nothing to do with computer software, right? But if they can still meet whatever FMVSS-like thing makes sense for a software-defined vehicle, and they can do that without needing the support, maybe it's okay they end support. What you can't have is them ending support and then leaving the customers hanging. And I'm hoping that any of them who are on here listening realize that it only takes one telling your customers, oh, your cars don't work anymore, but they're only 10 years old. What's that going to do to your brand reputation? Why don't you have a plan before 9.9 years and then make it up as you go along? That's just not a good idea.
Yeah.
So I think what you hear Phil and I both talking about from very different perspectives and very complementary perspectives is the opportunity of change and the challenges ahead with electronics and AI infused technologies. So I want to drive this for a moment here. I know we're running out of time to action. If I was sitting on the board of a Fortune 500 or Fortune 1000 company right now, charged with developing AI and electronics goods, I'd be asking the senior leadership, what are you thinking about here? What are you planning for? If I was the CEO, CTO, COO of any of these companies, I'd be asking my team, how are we going to address the life cycle challenges here? There are no easy answers. The opportunity really is to begin in corporations to be thinking about the flexible business models that are going to be needed to reap the opportunities of long-term deployment of these systems. So if I sit in the board seat, I want to know from my the senior leadership team, what are you thinking about here? And if you're not, quite frankly, you're probably not. This doesn't mean we're going to change our business, but if you're not thinking about this, you're not the right senior leaders here today. Now, I don't necessarily, you don't have to have a perfect answer to me. But if you're not thinking about this, you're the wrong CTO for my organization.
And I would come out with a similar thing, that whenever the hardware in your product is 1 generation old, then you need to have a plan for when it becomes 2 generations old. And the plan is either you retire the product and turn it off in the field, or you better have some other plan, because by the time it's 2 generations old, you're going to have trouble with end of life for spares, and it's not going to run the newest software and all these other things. And that includes software technology, hardware technology, network technology, and all this stuff. Let's say I have a sewing machine that takes 5-inch floppy disks, right? I mean, well, actually, there were ones that took the 3-inch disks, right? And all this other stuff. You have to have a plan, and probably about the time it's 2 generations old, you need a new plan, and it takes time to have that plan. So 1 generation old is when you need the plan to kick in by the time it's 2 generations old. And if your products last 3 years, you're probably fine. If your products last 10 years or more, you have to have a plan.
Now, let me flip this around for a moment. If you're a product strategist in an organization, work through your scenario plans, scenario A, scenario B, scenario C, so that, you're pushing up in your organization. I don't have the answers, which scenario is right or wrong, but here's the issues we got to deal with. Start the conversation. And that's the most important thing we can do today.
I like the way the two of you put it. I mean, there is the part where Brian talked about, you don't have to have a solution, but Please don't tell me you're not even thinking about it. And then it graduates to Phil's position, which is, okay, this product is going to be 1 generation old, a few years from now, and then you're going to have the second generation. Please don't tell me you don't have a plan. You have to move from not having a plan, but thinking about the problems, to having a plan that can be implemented. And I think, we just saw a question from an audience member, your concern and your fear right now is that we're at no plan and no ideas of what we should even be discussing it. And that is a huge concern.
Yeah.
And Bo, I think the organizations who think forward right now and begin to form those plans, whether they're toaster oven manufacturers or auto companies, the folks who begin to think faster and the ones who begin to build plans are the ones that are going to be the most successful over the next several decades. So if you're an auto manufacturer out there and you're really thinking about this stuff, you're the one I want to buy the stock on. All
right. Very good, gentlemen. So we got now the new hashtag, what's your plan? And that's what everybody should be asking when we all go out and talk to companies. All right. Thank you so much for sharing your views here. It was very provocative. And we would like to keep this going because it is a new topic. Well, it may not be new to you both, but I think for a lot of people, it is an eye-opening discussion. Thank you very much.
Thanks for the great conversation.
All right. And for our attendees, thanks for sticking around. And your next session will start shortly. So every session has its own unique link. Refer to the agenda, or if you signed up for this specific session, check your email for the link to the session. We look forward to seeing you in the next session. All right. Thanks.
Thank you. Thanks, man. Thanks.
Bye.
Bye.